Thank you. So my name is Peter. I am a developer advocate at Google, which means I get to play with new technology and exciting new stuff like SwiftUI and Firebase all of the time, basically. But I'm going to show you something that I've been working on for a couple of weeks now to do something that is not just playing around, but a real app that hopefully gets out there in the real world. Okay, so who here likes coffee? Okay, so the problem with coffee is that if you have too much of it, you'll get all jittery and dizzy. And especially if you're at a conference, that might be a problem because all of the people get jittery and dizzy. And then, it all shakes up. So I thought, how about creating an application that helps us to track how much coffee you used. And before we get into the presentation, I'm going to quickly demonstrate the application. Let's see how it goes. So we'll use the QuickTime player. No, there we go. Okay, it's called Caffeinated. Okay, great. So Caffeinated looks very much like a water tracking app that you might be aware of. And I'll show you the water tracker app in a minute. So this is the main screen, and it allows me to add a drink, but the problem is currently there are no drinks. So let's go into the settings and generate some sample coffees. And then go back to this page, and then we can navigate into all of these deliciously looking coffees, and then add one, for example, and we'll update our caffeine consumption because the goal is to stay below 100%. And how does it know how much caffeine I'm allowed to consume? Well, it's in the preferences. So 480 milligrams of caffeine is about what a person of my age and size and my gender should consume. So if I turn this up to 4,000, it should change this to 1%, right? So that sounds about right. Let's add a couple more coffees, latte macchiato, one more breve, and that's it. And then also we've got this nice little screen which shows us the history. And because it aggregates based on hours, all of the coffees I just added are aggregated into the 19 o'clock time slot, basically. So let's add a couple more coffees, some random coffees. So this is for today, this is for the current week, for the month, and for the year. So you can see that it displays everything very nicely on this nice little screen. Yeah, so that's the application that we're going to talk about today. Oh, and by the way, if you don't know why this looks very familiar, this is the water tracking app that I basically just ripped off. I hope so it's called Waterminder, so go and check it out if you like. It's a great water tracking app. All right, so that was the very quick demo of how the application looks like that we're going to try to build today. So let's look at the technologies that we're going to use. So first of all, SwiftUI and then Firebase later on. Let's talk about SwiftUI first. So who here has played around or written something using SwiftUI already? Okay, so that looks roughly, and people upstairs, how about you? Okay, so it looks roughly like half of you have played around or shipped something. Who has shipped? Okay, no, one person? Awesome. What's it called? What's your app called? You won't say, okay, maybe later. Okay, I'll be interested to hear about your experiences with it. Okay, so for the benefit of those who haven't yet had the chance to play around with it, we're going to do a quick tour of it. So SwiftUI is a declarative way to build your UI. Everything that we talk about is a view. So a button is a view, A label is a view, even a screen is a view, and everything is a struct, which helps, but also is a problem. You build UIs by composing things, so you put structs together, you put your views together, and then they build larger and larger things. And in order to manage all of this, you have to refactor all of the time. So for example, the chart I showed you, that's a lot of things going on, right? So you've got the bars, you've got the background, and then you've got the labels. So all of these are views, and I just want to have one bar chart. So I had to refactor this into one component. But the good news is it's very, very easy, and I'll show you in a minute. And views are a function of their state, and this is the real big news about SwiftUI. So instead of having to think about, okay, so the user clicked here and they entered some data there, and how am I going to update the UI here and over there and in all the other places in my application, SwiftUI is going to take care of that for you, mostly automatically. Why do we do all this? Because we want to have better state management, right? So we don't want to run into a situation where you update something in your UI and then it doesn't update in another part. All right, so this is how SwiftUI looks like if you get started. It is a very, very basic boilerplate thing here. So everything starts with the content view, which is a struct, which is a view. It's got one property called the body, and it in turn returns exactly one view. So you might be wondering how you can build something more complex if you only are ever allowed to return one view. We're going to see that in a minute. So let's see if I can handle both the microphone and my keyboard. Probably not going to work very well, but let's see. Okay, so I think it's this one. Yeah, there we go. All right, so this is what you get when you start with SwiftUI. So on the left-hand side, you've got your source code. On the right-hand side, you've got the canvas. And it's currently paused, so I'm going to resume it by clicking on this button up here. And while it's building, basically, we can talk about what we see. So first, those couple of lines are the view, and this down here is the specification for the preview. So we can specify exactly how the preview is going to look like as well. So by now it should be showing something. Okay, all right, so let's try to change something. So as soon as I start typing anything here, it will update the UI on the right-hand side. So let's now see how we can do more than one thing. So I said, you know, it has to return one view, but we'd like to return more than just one view. So in the list of coffees, you saw that there was a table view cell essentially with a headline, a description, and an image. So let's see if we can rebuild some of that. You know, okay. So I'm going to drag a text into the preview area here, and I can basically align it anywhere I want. So I like to drop it down here. So I've got a placeholder right now, and what happened is, the source code was updated. It inserted a vertical stack wrapping those two text fields or labels, essentially. And then let me update the placeholder. Espresso. All right. Don't pay attention to my typing. I think you get it, right? Sorry for that. All right, so Now let's align those two labels. So I'll command click on the stack and then show the SwiftUI inspector, left align. It automatically updates the preview and does this by inserting the alignment attribute here. Okay. Let's do one more thing and then we'll go back to the slides because it's really cumbersome doing this with the microphone. Okay. SwiftUI inspector, and then we'll change the font to title. And this is a nice way to learn the API, right? So I can go in and now that I've learned that I can use font, so weird not using both hands. Okay, I can basically control space and then say, okay, I'm going to use a caption here. And that's a nice way to discover the API. Okay, so it's probably even less fun watching me trying to type than it is for me. So let's go back to the slides. Okay, so essentially, it's a lot more fun to do this if you do it yourself. And building UIs with SwiftUI is really straightforward, and it's easy to get really amazing UIs done, as you probably can confirm. And you hopefully have seen, because the demo I showed you, that's entirely built in SwiftUI. So now let's talk a little bit about Firebase. And the next slides might look a little bit like marketing, but they're not supposed to be. So here, who here knows Firebase? Okay, so most of you. Who has used the real-time database? Firebase real-time database. That's a few. Who has used Firestore? Fewer. Okay. So Firebase essentially is a platform that provides a bunch of tools to help you build better apps, improve your app quality, and increase the number of users. So you see a lot of products down there. If you're interested in those, go have a look at bit.ly what is Firebase. Today, we're going to talk about just one product, Cloud Firestore, which is a cloud-based document-based database that is near real-time. So most of the applications many applications that we build look something like this. So we have shared data, and we want to share the data with other people. So I might have a to-do list, and I want to share the to-do list with my wife, for example. Or I might have multiple devices, and I want to share my data between multiple devices. So I'm working on a document, for example, and I start on my desktop, then I'm on the go, and I have an idea. I want to put it into the document. I pull out my phone, and I want to insert it into the document. So the same data, but on a different device. So if you try to do this on your own, then the process probably looks something like that. So you need to have some sort of database somewhere and an API server that faces the public or your users. And the API server accesses the database, and then users can use your API to pull data, but you want to prevent everybody from pulling data, so you have to have some authentication for users to sign in. And then you have to have some sync logic to synchronize between your backend and your mobile front end. So that's that. And then you need to store it on your mobile device as well. So if you've tried this before, you know that this is a lot of work and it's not always fun. And if you want to do it cross-platform, then you need to do it again for all of the platforms you want to support, which is why a lot of people are looking into cross-platform frameworks. So we thought maybe we can do something else. So instead of interfacing with the server, how about we talk with the database directly? And this is what the Firebase real-time database and Cloud Firestore are all about. So Firestore allows you to effortlessly synchronize between all of your devices without having to implement the sync logic yourself. It has an offline mode, which is on by default. So everything you do is offline capable. If your device is not connected and you add something to your to-do list, for example, and it comes back online, it will automatically reset. And if you are not interested in synchronization, automatic synchronization at all, you can do one-time fetching if you like. So for example, if you've got like a really big chunk of data that you want to pull down, it might be worthwhile doing that in a one-time fetch. Cool. So how does it look like? This is a document. We've got a couple of attributes. Yeah, I hear people smiling. You get the joke. And then there is the data. And as you can see, we've got a little vector in here. So that's a subdocument essentially, or not a subdocument, but a complex type that we can insert into the document as well. So we've got strings, numbers, Booleans, binary data, structured data, and arrays. And then all of our documents are organized into a collection. So for example, a collection might be all of your to-dos or all of our coffees. And then those documents in turn contain collections, and those collections can contain documents and so on and so forth. So you can nest this almost at will. The good thing is, if you query your database with a query, for example, like this, get me all the restaurants in Cairo and order them by their rating, but only give me the first 10 after they're ordered. No matter how many restaurants you've got in your collection, the speed of the query is always the same. It only depends on the size of the result set. So no matter if you've got a small collection of restaurants or a really, really big collection of restaurants, the speed of the query is always the same, which is really good news, I think. Okay, so let's get back to how to use Firebase in your iOS project. I wanted to tell you it's basically just 3 steps, but it's 5 steps, which is not too bad either. So you create a new Firebase project in the Firebase console. Then you need to register your iOS app, which is basically just inserting your bundle ID into the console. Then we produce a configuration file for you, which tells the Firebase SDK exactly where to find your Firebase project. Then you install the Firebase CocoaPod. And then once you've done that, in your application, you only need to call Firebase app.configure, which will then load the configuration file and do all of the connection magic. And that's basically it. And then you can start using all of the APIs. So let's have a look at the data model for the coffee tracker application I showed you earlier. So on the left-hand side here, you can see that we've got basically 2 collections, one for coffees and one for users. And the one for coffees is selected. So you'll see all the documents which contain coffees. And then this is a coffee document. And you can see that it's got a number of attributes. It's obviously the cappuccino. It's got a short description, a long description, and the caffeine amount. If you ever need lorem ipsum for coffees, there's Coffee Ipsum. I'd recommend. So how do we fetch data from Firestore? Oh, that's a pretty big lag. Sorry. Okay, so we start with getting the collection of coffees, as you can see here, and then we register a snapshot listener. By doing this, we get all the updates. So if I go into Firestore and change anything, I will get updates in my client application as soon as I make the change. The change gets sent into the closure. Can you see this, by the way? Can you see the highlight? Okay, awesome. It gets sent into the closure, and then we can, and the snapshot essentially is all the documents that are affected by the query. And because we currently query, give me all the documents, we get all the coffee documents. So we can now iterate over all the coffee documents and then pull data using this extremely dangerous and non-type safe syntax, which gets even worse. And as soon as we have that, we will construct the coffee, append it into our collection of coffees, into our local collection. And then once we've done that, we will assign it to our root level collection, basically. So this is how you fetch data from Firestore, and it's only just so much text because there are so many attributes. And obviously, that's a lot of repetition. So can we do better? Yes, we can. So a lot of people have asked us to implement codable support. It's been a very much requested and very long-running feature request. And we finally released it in October. And it makes everything so much easier. So this is how it looked before. And this is how it looks now. And it's only, it looks almost the same amount of text, which is only just because I inserted the coffee structure as well. So first of all, we need to make sure that it's codable, of course. Then it needs to be identifiable because we want to use it in a table view, and we're using the document ID. The document ID is the path to this document, which is unique because every document ID is unique. So hence, it's identifiable. And here is our snapshot listener. And this is where we iterate over the documents. And here we do our mapping. And now it's type safe and nothing can go wrong. Or if things go wrong, we will get an exception and we can properly handle it. All right, how to save data to Firestore. So for this example, let's look at how we would store if the user says, I just had an espresso and we want to save the consumption data. So we go into the user's collection and then we go into the consumption sub-collection and we add a document and we add it from consumption. And consumption basically is just a struct with data, and this method call is here thanks to our codable support. Again, if we didn't have it, you'd have to write a lot of code yourselves. So how do we know about the user? I didn't sign in the application, so how did it know I'm a user and what's my name? There's a thing called anonymous auth in Firebase. Anonymous auth basically helps you to let your users use your application without requiring them to sign in. I mean, like, how many times have you downloaded an application and the first thing it said, can you please sign in using Facebook, Google, Apple sign in, or username, password? What's the first reaction? Think hard if you actually want to use the application and then uninstall, mostly. So anonymous auth helps you to get around that because it signs you in anonymously. Every user gets an anonymous user ID, which is based on their device ID, and we can use this user identifier to store information in the database. And this is how it looks like. So you just call sign in anonymously, you get an auth result. In the auth result, you've got a user object. You can query if it is anonymous, and you can also get the user ID, and then you can use the user ID everywhere you want to use it, for example, to store information in Firestore. And this is why we know who the user is. But we still don't know who they really are. It's really an anonymous user. We don't have their profile picture. We don't have their their username. We just have this ID. Great. So another thing that we recently launched is support for sign-in with Apple. So let's assume the user has started using the application and now they really dig it, and now they want to, use it more. They want to share their coffee consumption statistics with their friends. So we need to know who they are so they can start sharing. So we can do that by asking them to sign in, for example, using sign in with Apple or any of the other authentication methods that Firebase supports. So this is all the code you need to, well, the core code that you need to write in order to support sign in with Apple using Firebase UI. So you request the default auth UI, and then you add this little line to make sure that if the user has previously been an anonymous user, that we upgrade their anonymous user account into a full user account, which means that all of the data that we already stored in Firestore is now safe, and we can use the same data with their Apple ID. Then you specify all the providers that you want to support. You can support more than just one. So for example, in this case, we support Google Auth, sign in with Google and sign in with Apple. And then you request the auth view controller, which you will then present to the user. So how are we on time? 20 minutes left? Awesome. Okay, so we can talk a little bit about data flow. So who here has heard about Combine? All of you. Well, most all of you. So Combine comes into play when talking about data flow in SwiftUI. And there are a couple of ways how to do the data flow in SwiftUI. So you want to know what happens if you display data, the user modifies the data, and what happens in all the other parts of your application. So there are a couple of approaches you can use. First of all, you can use plain properties and bind them to your SwiftUI views. Obviously, that means that they can't change, at least the user can't change them. Then there is add state, which allows you, or which asks SwiftUI to basically take care of the state handling for you. There is add binding, which you use if you have a view and a subview. So you have data in your view, and then you want to use it in your subview, but the main view should own it. That's when you use binding. There is add observed object, which requires that you use a class to capture your data instead of just using structs, but which gives you the opportunity to listen to any changes on any of your properties that you publish on this observed object, which is, one of my favorites. And then we've got environment object, which is very similar to observed object, instead of passing your objects around manually, you'll basically just register them in what we call the environment, and then you can pull them out of the environment everywhere you like in the child hierarchy. There is a really nice article that explains this in very much detail, and I would recommend reading this. It is the best I've read so far. It's very thorough, and it's got this very nice example. It's well worth reading. Okay, so let's look at a couple of examples. So this is a snippet from the graph I showed you earlier, and each of the bars on the graph. Oh, we're still not there. Did you take a picture of that already? Let me go back on my slide and then. Maybe I'm disconnected. Oh, it worked? Oh, okay. Okay, cool. So I'll have to do what you aren't supposed to do, look at the slides instead of looking at the audience. Okay, so this is a snippet from the bar chart I showed you earlier. And each of the bars on the chart is a bar, obviously. So because the user can't change the bar chart, we'll basically use just the property approach here and subscribe to this bars property, which is good enough. So we can iterate over the bars. Well, the highlight moves down. Does it? It does not. Okay, so there is a for each loop down here. And we iterate over the bars. Okay. So the next slide, which will come up in a minute, literally. Oh, there it is about add state. So if you recall the UI, we had all the tabs in the bottom, and when the user switches between the tabs, we want to keep track of which is the selected tab. So we're using add state here because the view is changing in reflection of what the user does, but also we might want to change that. So for example, I might want to specify that instead of on the leftmost tab, we want to start out on the first tab or the second tab, for example. So this is why we track selected tab using a state. Okay, and then observed object, observable object, there we go. So this is the coffee list, and here we've got an observable object, which is a view model, and this is one of the recommendations I would give. You know, when using SwiftUI, I have the impression that using view models is a very good approach because it helps you to encapsulate the data so that it matches what is on the view on your screen, and you can very neatly organize both the data and any actions that you want to bind. Okay, so we've got the coffee list view model. It's an observable object. I can't even see the highlight. Okay. We observe it in our view. Okay, next slide. The next slide talks about environment object. So it's basically an observable object, but it's put into the environment. Maybe if I switch. Ah, there we go. Okay, so in the top, you see the observable object, and we call it app state because it contains our coffees and our consumption. So this is the core data that we want to deal with in our application. And then the next lines, app state and content view, basically build up both the app state and the view that we want to present as the main view. In the lines below that, you'll see how we construct the root view controller and inject the app state into the environment. And that means that we can access the app state literally in every single view that is a child of this root view, except for if we start to present stuff in a model, because then it's a new environment and we need to inject stuff into that environment ourselves. Okay, so and the final slide I'd like to show you is a graph which, there we go. Okay, so on the left-hand side, we've got Firestore, or basically any other data source that we want to use. And then we've got the app state in the pinkish box here. with all our data in it. We store it into our environment. The main view refers to that, and then the main view will pull information from the environment and then assemble it into view models that it will then pass on to its subviews. We do this because it is much more manageable to have things and data and actions encapsulated in view models than instead of having your views reach back into your environment and pull stuff down from there. So it's basically just to make things more manageable and also more testable. Okay, so let's see if I can show you the application in its final state. Let's get QuickTime up again. File, new mover recording. Not bad. Okay. Okay, and then let's also go to Firestore. So in the background, you can see Firestore, and let's close Keycaster. And I'm currently signed in. I've had a couple of coffees. So let's add a drink. So 197, let's add another one. 119, oh yeah, that's because we're still here. We should update this to more reasonable amount, so 480. Okay, yeah, looks more like it. Okay, so, but instead of doing that, you know, let's go in and I'm going to delete what's in the database. So we're still using local data. And now let's go ahead and generate sample coffees in the database. So here are our coffees. And now I'm going to go in and drink an affogato. And let's have an espresso as well. So we should see a user now. You know what? Let me start the application again. And let's not use this Xcode, but Xcode. This one. Okay. Okay, let's try this again. Affogato. And now let's update the database. And there we go. So here's our user. This is our anonymous user. And let's have more drinks. So we can see the updated consumption here. Well, you can't. Oh, sorry. I can. Okay. Let's do one more. Okay, so you can see how it updates, and it's hard to see, but every update gets a green background, so you can see what it's updating. And let's let's do one thing which you hopefully should see. So I'm going to go in and I'm going to update the consumption data for one of the coffees I had. So let's change the amount of caffeine for this one to 700, well, 7,000. Let's do that. And you can see that the UI updates automatically. So let's turn this back to a more reasonable amount, 75. And the UI should go back to what it was before. So that's that. And finally, let's see how upgrading the user works like. So I go in and then I tap on sign in. I'll get a sign in with Apple UI. Okay, I'm now signed in using Apple. And I can now add drinks, and you can see in the UI here that I'm signed in using my personal account. The little A here says I'm signed in using Apple, and all my data is now connected to this user account starting VV8. So if I go into the database, there should be a collection labeled VV8, and here it is. So this is tied to my Apple ID. And there you go. All right, back to the slides one more time. Okay, so this was how to use Firebase and SwiftUI together. And what's my conclusion? So using SwiftUI is great fun. It's easy to achieve great results in a short amount of time. Documentation is a little bit lacking, but thankfully, the community is doing a great job with contributions, articles, and building up a separate set of documentation, essentially. A couple of things don't work yet. So for example, if you think about a list view and you want to connect custom actions, that doesn't work yet. You can connect a delete action. That works because the DSL is already specified for that. But if you want to, for example, register an edit action, that doesn't work yet because there is no DSL for it. So if you have any gaps that you need to fill, you can use UI View Controller Representable, which, by the way, I did for integrating the sign-in with Apple functionality. So even despite me not telling you, you basically saw SwiftUI and UIKit in action in this application. How about Firebase and SwiftUI together? So I think it works really well together. I haven't run into any critical issues so far. The Firebase team is really keen on hearing your feedback. So if you use Firebase, no matter if you use it in conjunction with SwiftUI or just plain Swift, Objective-C, or even Android or Flutter or what have you, let us know. Give us your feedback. We're always eager to hear. The team is very active on GitHub. So you'll see the engineers building the tool actually being very active on GitHub. So you can talk right to the people who build it. Yeah, so I personally think SwiftUI and Firebase is a love story. And with that, thank you very much. If you do interesting things with Firebase and you are active on Medium, we want to hear about it. So there's our Medium publication. We're always interested in guest authors. So if you have anything in the pipeline, come and talk to me or reach out to us on Twitter and Medium. There's also an article which explains what we're looking for and how to submit articles.
Thank you, Peter. Questions?
Yeah, first of all, thanks for the presentation. Maybe a small suggestion, like for the chart view, I wouldn't use views to draw the bars. I would use the one view and draw on canvas. I'm not sure. Probably it's also possible in SwiftUI. Another thing is that maybe you explain to us what's the difference between real-time database and
Firestore?
Firestore, yeah, because they look similar. How to choose between them and what's the thing?
So real-time database is the product that originally was Firebase. So it is it has been around for a long time, and Firestore, it is very similar, but it's basically a complete rewrite with all the things that we learned about during the process of building a real-time database. They have slightly different models of how we charge for them. So you probably know that Firebase has very generous free limits. So if you get started, you'll be able to use Firebase essentially for free. Only when you start building really, really big applications with hundreds of thousands of users, you'll be charged for it. And there are a couple of pricing models. Firestore is a document-based database, whereas in real-time database, essentially everything is just a giant tree of JSON, which has challenges.
Yeah, does it mean that real-time database is going to be deprecated? And
no, it's going to stay around. So if you use it and you're happy with it, keep using it.
Thanks.
Other questions?
Can you perhaps compare the UI model of SwiftUI with Flutter? Because it seems pretty similar.
Yeah, so to be honest, I haven't used Flutter myself, but I can try. So I think the biggest similarity is that both are declarative approaches, and you can see this going around, in many different places. So I think the biggest difference here is that SwiftUI, so Apple always says it is cross-platform. What I mean is it is cross-platform in their ecosystem. So you can use SwiftUI to build for the Apple Watch, for Apple TV, for the Mac, for iPad OS, and for iOS as well. So in this regard, it is cross-platform. Flutter is cross-platform across the other platforms. So you can use it on Apple platforms, you can use it on Android as well. You can use it to build for the web. So if you want to use, if you need to build a real cross-platform application, that might be, a good reason to use Flutter. But again, the question of should you use the cross-platform tool or not, has so many sub-questions that you need to answer. That it would be no good idea for me to give you a recommendation, because you'd have to know much more about what is your goal, how much time do you have, how big are your engineering teams, is it a throwaway app, or is this for a product that you want to keep around, is it a public application, and so on and so forth.
I can just comment that Firestore has a interesting REST API as well. Came pretty handy for mocking the backend, which is not yet there, or maybe never will be.
Yeah, so if you if you want to build some kind of backend logic, then you can use cloud functions, which tie into many of the Firebase products. So for example, you could write a function that is being triggered when, for example, a user deletes their user account. So you could go in and then delete all the data that had been connected to this user, for example. Or you could use a function to do other things like resizing images or reacting to events like somebody created something in Cloud Firestore and you want to do something based on this data. So it's extremely flexible.
Just one more question. You mentioned querying does not depend on the actual size of the data set, just the result. So how does that work? Does it have to be local data or?
No, it works because we create an index for all the attributes. So if you just query based on the plain attributes you've got in your objects, then it's extremely fast because there is an index. If you do compound queries, then obviously this breaks, but we will tell you, and we will tell you, oh, this query is going to be slow. Please click here. So we create a hyperlink for you to click on, which will take you to where you can create the index for this query.
Yeah, I saw that. Yeah, cool.
All right.
Could you tell a little bit more about the authentication and also authorization? So basically, you said that there is an anonymous one, meaning that when I delete the app, I haven't registered yet. So then all my data is basically lost. I wouldn't be able to.
Mm-hmm. So we support a number of authentication mechanisms. So anonymous auth is the easiest way to get started. Then we support signing in with email and password, email and link. So basically you send the user an email with a link, they click on the link and they get into your application. They don't have to remember or even create a password. There is phone number auth. So they register using their phone number, you send them, or we send them an SMS, and that gets them into the application. There is, we support all the major identity providers like Facebook, Google, Apple, GitHub, Yahoo. And if that's not enough, you can even write your own.
But then, like, for example, you showed in your code basically that a user has a user ID and it's a stable one, right? It's the one for this user, and you use it as your hierarchy in your database, basically. Is there a possibility to say, okay, I want to restrict only users who are actually this user to read and write into this subtree? I think there are rules, but I'm like...
Can you say that again, the last part?
Right. So is there a possibility for authorization to say, like, only a really signed in person can actually read and write from this subtree?
Yeah, definitely. So there is something called security rules. So you could say, okay, everybody can read and write to this path in a database, but only people who have actually signed in are allowed to read this part of the database, and only the user themselves may read and write anything below this tree in the database, which is identified, for example, by their user ID. And you can also use custom roles to do things like mark a user as this user is an administrator, and they have, extended rights, for example.
Okay.
Yeah.
Yeah, thanks.
I saw that you installed Firebase via Cocoa Pods, of course. We are migrating right now to Swift Package Manager, and you're one of the last packages that are not compatible with Swift Package Manager. I also saw that there's an issue on GitHub for that, and there are some issues. I don't know. I don't remember if it's some libraries behind that can't be migrated right now. Do you have some more insights when it will maybe come, or is it not possible at all?
Oh, it is possible for sure. It's just a little bit of work. So it's true. Default way to install Firebase into your application is CocoaPods, but you can also use Carthage. And Paul is currently working on making sure that it works with the Swift Package Manager. I think what you're referring to is that some of the dependencies are binary only, and that is currently a problem, if I'm informed correctly. So we have to resolve that and see ways how we can split this out or talk with those dependencies if they can provide binary source code. It's the Firebase team's goal to do as much as possible out in the open and in open source. So our goal is to have all the SDKs as open source to get feedback from the community. And as you mentioned, there is this ticket on GitHub. You can see what's going on. I don't have more information than what you see on the ticket.
Thank you very much.
You're welcome.
So thank you, Peter.
Thank you.